We are discussing about the abrasive processes. In this abrasive processes, till now we have seen the grinding process, in which introduction to grinding, grinding wheel specification, belt grinding, what are the problems, what are the solutions of the grinding wheels and all those things. Now we proceed to the grinding fluids, that is also a part of our syllabus, that is called machining fluids. So in this aspect we are studying the grinding fluids. The grinding fluids, basically if you see in a machining operation or the surface grinding, here in this region you can see lot of spark is generated because of the friction that is between the grinding wheel as well as the workpiece surface. So in order to reduce the temperature generation and the heat affected on the workpiece and all those things, always people will use the grinding fluids. Okay. Grinding fluids can be lubricant based or it can be coolant based. So both are there, depend on what type of application, whether you are going for high speed or whether you are going for very low speed or whether you are going for medium. This will decide which type of cutting fluids you are going to use in the particular grinding operation. But as you have already seen the grinding wheel specification, in this one, which is the most important one that will have influence with respect to the grinding fluids, that we have to see. See, as the abrasive type, you don't have any much thing, because whether it is alumina or a silicon carbide or diamond, whatever the things. So whether the grit size, no, it won't have much effect, because what is the grit size you are using, whether it is you are using a medium or coarse or something. So grade is the bonding between abrasive particle and the bonding material, that is called wheel bonding material. So whether it is hard bonding or soft bonding, so it also don't have structure. The structure, if you see what is happening, if you see the structure is nothing but open structure and dense structure. If you are going to apply the cutting fluid or the grinding fluid, basically it tries to enter, or it will tries to help the grinding wheel to not load, and it also helps the grinding wheel in terms of cooling and all those things. That's why most important factor whenever we consider about the grinding fluids, you can say the structure is the only parameter that can have some influence compared to others. Anyhow, the bonding, different bondings are there, vitrified bonding to the shellac bonding, rubber bonding and all that. Those also don't have much play. Okay, only particular specification, that is called the structure, which is having some influence whenever you apply the grinding fluid. The grinding fluid significance, the presence of boundary layer or air around the periphery. If you don't use the cutting fluid, normally we consider it as air will be there between. If you see this region, you have workpiece as well as the grinding wheel. So the air can penetrate into this one. If you are applying the cutting fluid, normally if you see, the cutting fluid plays a major role in terms of burning of the workpiece. It will reduce the burning effect and chip burnishing. At the same time, it will also cools down the machining region and all those things, lubricates the machining region so that the temperature generation is very less and all those things. There are varieties of cutting fluid application. People can go for one nozzle application, or people can go for the multiple nozzles also. Here you can see here multiple nozzles. So this will enhance the particular grinding operation efficiency by dislodging the wheel loading and all those things. Wheel loading, as you have seen, the chip materials are clogging between the two successive abrasive grains. Okay, that is called wheel loading. So the grinding fluids will help to not clog the material. Applications of cutting fluid in grinding, it is generally accepted that the heat generation is a limiting factor in the grinding process due to the thermal damaging. And what will happen if there is a heat generation in the grinding process? There will be the thermal damage with respect to the workpiece. it come back the energy transfer because the thermal energy transfer takes place. And whenever you use the cutting fluid, what will happen? The thermal energy it will extract from the machining region. So these cutting fluids also move limit amount of energy transfer to the workpiece through debris flushing and lubrication and the cooling effect. What will happen? It will take the temperature generation in the machining region by debris flushing. That means that you are flushing the debris that is between your grinding wheel as well as the workpiece, and the cutting fluid also help to dislodge the clog material. It will help in terms of lubrication, because the proper lubrication if you provide, what will happen? The friction between the grinding wheel as well as the workpiece will reduce, so the heat generation will be less. The cooling effects, the workpiece has to be cooled so that it won't go for thermal softening region and all those things. Okay, there have been many new and existing systems of, so that means that not these cooling applications, like there are many varieties of techniques are there, like flood cooling is there, multi nozzle that you have seen in the previous slide, single nozzle. So nozzle positions also can be varied, whether you can go for 0 degrees, whether you go for 15, 20 or 30 or something, and the same time standoff distance between the wheel as well as the nozzle. And solid lubricants also used, minimum quantity lubricant that is called sustainable grinding also can be used in the cutting fluid applications. Cooling mechanisms in the grinding, if you see the need of cutting fluid, the cooling mechanisms, the need of the cutting fluid, if you see the cooling mechanisms, type of fluid, health is, you can divide into 3 segments. Then the cutting fluid application, so useful fluid application, normally common nozzle designs is the one. At the same time uncommon nozzles, basically whenever you are going for the solid lubricants or floating nozzle, there are some varieties of nozzles are there. So this type of uncommon nozzles also will be there. So you have to choose according to your requirement. What is your requirement? What is my requirement? Whether I want to remove the material in a bulk amount, whether I want to remove the material for the surface finish, whether I have to do the form grinding or normal grinding or centerless grinding, which type of grinding that I want to use, depend on that you have to choose your nozzle as well as the cutting fluid. So the types of nozzles, if you see, the first one is the basic shoe nozzle. This is the one of the common and conventional type of thing, where if you see, normally these shoe nozzles are very effective because they able to maximize the amount of cutting fluid passing through the cutting zone. Okay, this is the cutting zone. So this is a workpiece interface and the grinding wheel interface, so that it can pass through the grinding fluid and it maximize on the periphery of the machining region. The other variety is floating type of nozzles. Here the floating type of nozzles will have the tension springs will be there, so that it can float as per the requirements of that one, so that you can send the cutting fluid into the machining region. Nozzle positions in the grinding, if you see, there are some researchers working on or worked already on the nozzle positions. You can use tangential position, at the same time you can use intermediate position, because you need certain boundary. Basically what will happen, if you are using here, the cutting fluid goes like this, so it will occupy the machining region. If you use here, what will happen, it comes through the boundary and goes like this. Okay, if you are using here, what will happen, it goes like this. So the nozzle standoff distance, that means that how far you are keeping this is one of the thing. At the same time, how inclinedly you are keeping this nozzle, so that the cutting fluid carry on the periphery of the grinding wheel, also studied by many researchers. Okay, the cutting fluid contributed significantly to improve the surface finish of the samples, because the cutting fluid, the conventional grinding process is considered to be one of the finishing process. That's why people uses it for the finishing. So the output as a operator that I will look is, I have to get a good surface finish on my product. That's why normally you play with the nozzle. It also appeared that the decreased nozzle distance from the wheel, that is nothing but the stand-off distance, how far your nozzle is standing away from the wheel. At the same time, flexible hose to the positioning of the nozzle. So how flexibly your hose is, that is previous slide we have seen that floating type, and these can also improve the surface finish. People have studied, so those people who want to study, you can use existing things, you can go through the literature, you can go through the what are the type of cutting fluids they have used, what are the workpiece materials, is if there any drawback, or if you can understand some good mechanics of this one, if you can understand some temperature measurements or experimentally, or if you think there is some things can be further done, you can take up this work as a research program for the masters and PhD people. There is another nozzles type that is called a dual nozzle, which we have seen the schematic in the previous slides. So here also you can use the coolant. There is oil which is coming from here. At the same time, there is a water also coming from here. Dual nozzles are there. The oil will help in lubrication. At the same time, water will help in cooling. So the coolant water was applied to the underside of the workpiece via the positioning valve so that it can cool. The second is with the conventional cutting fluid, normally the RZ, if you talk about, whenever I was talking about the surface roughness in the machining process, RZ is nothing but the maximum peak to minimum valley. If a surface roughness is like this, so this is nothing but your RZ. So maximum peak to minimum valley is nothing but your RZ. So this is will be normally the maximum. That's why. So this is 3 mm in normal single nozzle. Whenever the authors are using multi nozzle, it is reduced to 1 mm. That means that the surface roughness is decreased, means surface finish is improved, that increased. That means better surface is achieved. Another one is also the grinding zone temperatures are greatly decreased. Okay, whenever the grinding zone temperatures are decreased, what will happen? The thermal damaging on the workpiece will decrease. So not only it gives a better surface finish, it also decreases the temperature. So thermal damaging also it is reducing. Okay, two benefits the authors got by using the dual cutting fluid application technique. So there are authors who has used the solid lubricants. So an ideal way of application of the solid lubricant in the grinding is putting this material or built-in supply lubricant, solid lubricant can be done. Okay, there are varieties. Wheel after slots cutting on it, so you can put the solid lubricants by cutting a slots. Another one is a slotted grinding wheel, where you can put the slots, as well as you can fill these slots with solid lubricants. At the same time, you can also put the solid lubricant sandwiched in the wheels. So basically you can you can sandwich here and you can use the solid lubricants. Not only this, people have used like a flood cooling. They have just taken the air, like minimum quantity cutting fluid that you have seen previously. So they are sending the solid particles along with the air, so that the jet of solid particles will go into the grinding operation. People worked on the solid lubricants also, but some people who are interested, they can explore more and more in this area. So for references, you can see some of the papers on solid lubricants for metal cutting applications as well as grinding applications by Professor P.V. Rao of IIT Delhi. So the Professor Rao's group works extensively on the solid lubricants and other things. So if you are interested, those people who want to explore about all these things, you can refer Professor Rao's papers. So and those papers also explain a lot of mechanics, what are the usefulness and all those things. So those people who would like to do the research in the solid lubricants in metal cutting as well as grinding operations can go through those papers. So sustainable. Whenever I was telling many times that the course title says machining and machining fluids. So at last what I want to say is whether whenever I teach about machining as well as whether I would teach about machining fluids, at last my ambition is towards sustainable. How sustainability I can incorporate so that a better output can come. At the same time, I can also help the operator in order to safeguard him as well as in order to make him healthy with respect to the emissions and all those things. Even though emissions are there, how to protect, that was one of the concern. If I cannot generate or if I don't generate any emissions, that will be better. That's why always I try to emphasize for the sustainability aspects. Here also I am going to talk about the minimum quantity lubricant or minimum quantity cutting fluid in the grinding process. Here you can see here in this grinding wheel is there, at the same time the workpiece is also moving, that is table feed will be there. So in the previous one, what will happen, the cutting fluid is a liquid which may not penetrate into the machining region between the grinding wheel and workpiece. That's why if I can send the atomized cutting fluid that can penetrate into the machining region and extract the heat by forced convection, as well as it also can lubricate that region. That is what the intention of MQL. So minimum quantity lubrication, if you see, so to avoid the adverse effect of the cutting fluid, the minimum quantity lubrication or the minimum quantity cutting fluid techniques came into existence. The minimum quantity lubrication refers to use of very minimal cutting fluids, that is 5 ml per hour to 500 ml per hour. So normally people will talk about 50 ml per hour and all those things. So 50 ml per hour means very less quantity with respect to the flood cooling, where you will spend per a minute half a liter or something. Okay, here per hour you are spending half a liter. So maximum. So this is about the minimum quantity. Over 2 billion gallons of cutting fluid is wasted per every year. So in order to keep the resources for the next generations, we have to minimize the cutting fluids utilization also. At the same time, 17% of the manufacturing goes to the product basically. So if I can minimize the cutting fluid, I can be competitive in the market by selling my product at minimal price. This is a known slide to you because I explained already whenever I was talking about minimum quantity lubricant or cutting fluid. So where you have two things, one is easy accessibility of the air one side, at the same time high convective heat transfer coefficient of the cutting fluid is mixed and form a mist, and it is injected between the grinding wheel as well as the workpiece. You can see here, say the mist is coming in and in between the workpiece as well as grinding wheel. Okay. So this mist will help not only in terms of providing lubrication, cooling, because of this forced velocity, because of this high velocity particulates or the molecules, because of the high velocity of this jet, what will happen? The clogging also can be removed, that is wheel loading will be minimized. The advantages is environmental friendly. One, there is no maintenance or the cost or the waste, lower thermal shocks, less clogging of the wheel. I was saying that if there is any clogging, it can penetrate and it can take out the clogging. So in this way, you can enhance the grinding efficiency of any particular process compared to your normal process. This is how you can see here the grinding wheel and the minimum quantity lubrication. The fluid is occupying here and the abrasive particles will be there, and this will remove the workpiece material. Okay, these slides are taken from one of the senior professors from IIT Madras. So thankful to the professor. So the researchers also studied about the droplet size. They experimentally validated the droplet size. The question is, whenever I am sending the cutting fluid and air, compressed air, and I am mixing it internally and I am sending it, what will happen? I am sending a atomized gas which is having high convective heat transfer. Now the problem is how to calculate the droplet size is the biggest question. For that purpose, Malveron analyzer is there. So you can, if you have that equipment, you can measure the particle size or the droplet sizes. The droplet velocity also can be measured using the high speed camera. Okay. So if you see here in the figure 1, this is a mist jet is there, the jet is falling in the grinding operation. You can see from the other view in the figure number 2, and the velocity can be calculated by high speed camera. At the same time, you can also measure the droplet size by Malveron analyzer. Once you have done, once you know the physics, if the people who are having some knowledge about fluid and all those things, who works in the fluid and thermal area, not only the manufacturing, they can simulate the droplet sizes. So they can check the droplet sizes as well as they can also simulate using the standard softwares, and they can validate it. So in the experimental results, if you see the people who has done, so flow rate they have varied like 60 to 80. At the same, by keeping the pressure constant, then they have varied the pressure 2 to 4 to 6. So they varied in this way, and they have seen the droplet diameter. So as you increase the pressure, basically what will happen, you will get smaller droplet size, obviously. So at the same time, you can also correlate with respect to the temperatures. What is the minimum temperature that you recorded is about 156 degrees. Like that, what is the effect of the flow rate, what is the effect of the pressure, and all those things with respect to output parameters like surface roughness, output parameters like temperature, forces, that is called cutting force, normal force. You can plot the graphs and you can check in the preliminary experimentation. This is the preliminary experimentation. Hopefully the authors might have done full experimental details. So you can go through Professor L. Vijayaraghavan's papers on grinding with MQL, so that you can get more details about this particular thing, because I have taken it from his papers. Wetting area calculation, this is another important area where whenever the droplets are falling in the measuring region, whether it is occupying the complete area or whether it is not occupying the complete area, that is one of the concern. For that purpose, you have to play with your particular cutting fluid. So what will happen if your alpha is 0, normally the angle will be here. So it is completely spreading. If it is alpha is less than 90, that is good wetting, that means that it is spreading the complete surface. If it is 90, incomplete wetting. If it is again incomplete, if it is more than 90, if it is more than 180, it is no wetting at all. Okay. So this is called, where alpha is called the wetting angle. Okay. So you have to measure your contact angle so that you can say whether my particular fluid will have better wetting or not, and all those things. Some of the surfaces are there. So this is taken, the picture, last picture is taken from Professor Spencer's website. This is not exactly for the contact angle measurement also. There is a gradient surfaces, but my intention here in this particular slide is to show you how a droplet, if I am putting a individual droplet on the surfaces, how the contact angle changes. That is why I have shown here. You can see the practically how the contact angle look like, how a liquid, if you are putting on a surface, look like with respect to the contact angle. So if my cutting fluid has a good spreading ability, what will happen? It will occupy most of the area of the machining region, and it can extract more amount of the heat. That we will see here. The contact angle, if you see the alpha, what will happen if it occupies this much, so it can extract more area. Assume that it occupies this much only, what will happen? This must extract only this particular area. Okay, that's why as spreading as possible you have to spread on the surface. If the better spreading is there, then the better wetting will be there. Okay, so when a droplet of a liquid of the, that is nothing but the cutting fluid resting on a solid surface create the interface angle between droplet, which is nothing but the wetting or the contact angle will, and wettability of the cutting fluid on the cutting evaluated by the wetting angle, and wettability of the cutting fluid on the cutting tool surface is one of the important factor, because substantial effect of the lubricating property as well as cooling property also you can show. Okay, if it has a better wetting ability on the surface, what will happen? It can have a better lubricating property, because you will have a boundary lubrication or hydrodynamic lubrication or mixed lubrication, depend on the type of lubricant that you are sending, at the same time how pressure you are sending. At the same time, if it is occupying more and more area, the cooling ability in that particular area also increases. So wetting area calculations, again the same thing, 2, 4, 6 bar they have used, and the flow rate also they have used. Here if you see what is the best thing that they have achieved is wetting area is 0.203 meter square per second is the wetting area, and it is covering around 33.15%. That means that it is covering one good amount of area compared to the other percentages. So in this way, if you can cover more area, what will happen? You can lubricate more area and you can extract the heat from the more area. Okay. At the same time, droplet diameter also you can see here. If you are increasing the air pressure, it is gradually decreasing. If your droplet size is decreasing, and the same time if you see the wetting area, it is increasing. So the more surface area, it is increasing, because if your droplet size is less, the surface area of that one will increase. The same thing is reflecting here, the droplet size versus wetting area. As the droplet size increases, what will happen? The wetting area is decreasing. So wetting area decreases with the increasing droplet. The larger wetting area leads to lower grinding temperature. Okay, if you can decrease this one particle size or the droplet size, you can occupy more area and more area, so that the temperature of that particular area you can take out easily. So lubrication reduces with the cutting forces and converging. So if lubrication also improves with respect to particle size decreasing, so that, or the droplet size decreasing, so that lubrication also improve. The same thing is reflecting from the region 1, region 2, region 3. As the region moves on, what will happen? The wetting area is decreasing as you increase the droplet size. The observations on the surface morphology, if you see, basically everything boils out to be what is the surface roughness that I got. If your particle size decreases, what will happen? There is no side flow. In the first one, if you see, the surface roughness is very higher, side flow is there. In the second one, if you see, the side flow is not there, but the surface roughness is very high. In the last one, if your particle size is very less, what is you are going to get? You are going to get a better surface and surface morphology, and there is no heating. At the same time, there is no side flow and all those things. For that purpose, the better thing you can go for the as minimum as possible the droplet size. This is about the cutting fluid application in terms of grinding. You can go for the flood cooling, you can go for different type of nozzles, whether straight nozzle, floating nozzle, shoe nozzles and all those things. You can go for solid lubricants where you can inbuilt in the grinding wheel. At the same time, you can go for externally like minimum quantity lubrication also, like solid lubrication, that you can, people those who are interested, I already said you can go through some of the papers of Professor Rao, that is called minimum quantity solid lubricants, or lubricants, also solid lubricants based grinding and metal cutting. Another one most important thing is minimum quantity cutting fluid in terms of grinding also. This is about the grinding fluids and its applications. Next we move on to the conventional abrasive processes. There are other conventional abrasive processes are there, which we see now is, we have still now seen the grinding process, wherein grinding we have seen, the grinding fluids we have seen. Now we move on to the honing process, then followed by lapping, super finishing, drag finishing, vibratory finishing, sand blasting, and if time permits, we also see some of the introduction to advanced abrasive finishing processes. Move on to the honing process. Honing process is one of the conventional finishing processes. Exclusively, this is used to finish the cylinder liners and cylinders. Honing is a finishing process in which tool is called hone. Okay, the tool which you go into see in upcoming slides, that is called hone. It will have a rotary as well as reciprocating motions. While the workpiece does not perform any type of motion, the workpiece will be stationary, and the tool will not only reciprocate, it rotates and goes inside, and rotates and come inside. That's helical path it will follow. So most honing done in the internal cylinder surfaces such as automobile cylinder walls. Mostly the application of this one is in terms of automobiles, cylindrical and cylindrical liners application, where I will tell you why you have to use this. The honing stones are held against the workpiece with controlled light pressure, because these are loaded by the spring load, and you can vary this pressure and you can perform the finishing operation. The honing held not guided externally, but instead floats are being guided in the workpiece inside itself. The honing stones should not leave the work surface, and the stroke length must cover the entire work length. Normally, if your cylinder liner is this much big, it has to go throughout and it has to come throughout, so that it can do the complete workpiece. This is called the hone. Basically, honing process is an abrasive process. The small amount of material is removed. That means the specific energy requirements is so high, like grinding process. Mainly internal holes are done. Okay, the honing are done by the honing stones. Honing head with honing stones, that is nothing but the hone, and whatever you are seeing here is a tool, honing tool. Honing stones are made up of abrasive materials, adjustable pushing springs. Basically, this hone will have the honing sticks, where these are loaded by the spring loads, and you can vary the spring loads on this. Whereas honing stones, it is called a single stone with a small bore. Normally, you will have a only single stone that is going to finish, because it will rotates and goes inside, reciprocates. So you can do. There are the multiple also. So in whatever you have seen in the previous slide, where there are 4, that is called multiple type. So you can, if at all I want to remove more amount of material, you have to go for multiple stones. The honing head, it will have a rotary motion, it will have a reciprocating motion. Honing stones are pushed to the surfaces by the spring loading honing sticks. Okay, so that you can apply whatever the required amount of pressure is required, because if at all I want, these are adjustable. Basically, if I want more amount of material to remove, you have to adjust according to it. If I want very less amount, you have to adjust according to that. So as I said, this is called reciprocating motion will be there, as well as rotary motion also will be there, because of which you will form the crosshatch pattern. You can see here the crosshatch patterns are clearly visible here. So this is called the honing process. Why you require the crosshatch pattern? In a engine cylinders, if you would have gone to the petroling stations in olden days, what will happen? They used to fill the petrol as well as they used to fill the engine oil also, that is lubricating oil also. What will happen? The engine, the piston motion will be taking place inside the cylinder. What will, in that circumstances, this lubricating oil will come between the piston as well as the cylinder walls, and smooth functioning will be taking place. That means the reciprocation motion of the piston will be smooth. For that particular application, you will have the crosshatch patterns. What will happen? It is not only finishing process. Honing process is not only the finishing process, it is also generate the crosshatch pattern, and this lubricant goes and sit in between this surface lay. That is, lay is nothing but predominant surface direction. So this crosshatch micro grooves are there, or the nano grooves are there along with the surface finish. This will go and sit there and helps the piston for the smooth functioning. That's why always, if you see these particular honing process is used in the cylinder liners finishing. How you can give or the impart the rotary motion and as well as reciprocation motion? Rotary motion is transferred with respect to gears, this gear 1 to gear 2 to gear 3, so that you can transfer this to the gear 4 and you can transfer to the gear 5. But the same time reciprocation motion you are going to get from this. Okay. So indirectly you are going to get the rotary motion as well as reciprocation motion. Then if you can synchronize both, you will get a helical path. If you see here, Ft is the tangential force as well as Fr is the radial force, and if you can combine, normally Ec is nothing but Fc is the cutting force. Electric motors are normally used for the rotary motion as well as hydraulic systems are used for the reciprocation motion, so that you can get the helical path, and at the same time it will come in a reverse direction also. Surface roughness, if you see, as I said, the crosshatch pattern will be generated on the engine cylinders or the cylinder liners. Whatever you are seeing here, this is the lay, that is nothing but predominant direction of the surface roughness or the surface finish. You can see this is reverse direction and this is going direction, so that you can get the crosshatch pattern. I was talking about the lubricant stays in these crosshatch patterns. As I said, this is not only a finishing process, it also generates certain pattern, and finishing always helps in piston motion in a free way. At the same time, this crosshatch pattern helps to retain the lubricant so that proper motion of the piston takes place. If you can see here, this particular area of the liners, cylinder liners, this, if you see here, you can clearly see the crosshatch patterns. Okay. These crosshatch patterns will help the engine cylinder liners. Applications, as you can see, this is the honing process. It will go rotates as well as reciprocates in an engine. So you can do the honing process. As I was telling, previously people used to do the engine cylinders itself directly, but it is a costly process because of the piston motion, the engines wear out and you have to change. For that purpose, people find some other solution, that is called cylinder liners. What they will do the honing process in the cylinder liners. These are the cylinder liners, and they just go and fit in the cylinders. So if there is a wear out of the cylinder liners, just take out the cylinder liner and replace with the new cylinder liners. This is the advantage, and it is a cost effective method also. In this way, if you have some time or nearby these companies are there, engine cylinder manufacturers are there, please visit the honing process. Some of the colleges or some of the universities, you may not have the facility of honing, but many of the institutes will have. You can just go nearby big institutes and you can visit, or if there is a small industry who manufacture the engine cylinders and all those things, you can go and visit that company for visualizing the or for seeing the practical thing and all those things, for seeing the how the honing process practically works and all those things. You can feel and you can also see the surface roughness measurement. Here I want to say some other thing also, not only the surface finish, surface lay, that is cross hatch pattern, but also you require out of roundness. That is nothing but you should get a perfect circle. If you are going to get a abnormal, what will happen? Your piston will, the life of the engine goes very bad. That means that you have to frequently change your cylinder liners. That's why you also to take care about the out of roundness of that particular liner also. There are many varieties of horns. One is solid type of things. If you can see here, whatever you have seen in the previous slides and all those things. There are the flexible types also there. So where you have a spherical balls will be there, and you can reciprocate it through so that you can do the honing process also. So there are varieties of horns are there. These are only 4 are there. As you can see, like a conventional single point cutting tool, grinding is a abrasive, millions of multi-point cutting tools. Similarly, the technology is growing in the honing process also. The people are using these type of things, and people also use this type of multi-point cutting tools also. So you can go for whichever is required and whichever is economic, whichever is causing less pollution, whichever is sustainable. You can choose according to your requirement. The lubrication or the cutting fluids in honing process, mostly the cutting fluids here you will be used is lubricants. As you can see here, these are all mostly lubricant type of cutting fluids will be used. So water based cutting fluids are not used. If at all used, very less amount of water based, because the cooling is not a criteria here. The lubrication is the major thing that the people want here. That's why always if you see the lubricant based cutting fluids are there. That means friction is a main culprit here. To reduce the friction, to reduce the heat generation in the honing process, this particular lubricant type of cutting fluid will be used, and it is a dominating one, not the coolant type of. That means if you see the table where the lubricant and coolant is there, people are going to use mostly mineral oil based cutting fluids. People who want to work on this one, there are very less papers on sustainable cutting fluids for honing applications. So if you have expertise on sustainable green cutting fluid development, you can also check those cutting fluids for the honing process also. That is can be a good area to take up as your master's or PhD thesis. This is about the honing process. The advantages of this particular process is it improves the geometrical accuracy and setting certain surface pattern. That means that to lubricate crosshatch pattern it can generate. At the same time, this will help in terms of lubrication at the cylinder piston interaction region. Same materials like grinding stones you can use. That is nothing but silicon carbide, CBN or polycrystal diamond. You can use similar type of grinding particles on the hones, that is called honing sticks. More precise shape, smaller gain you can use. So what are the difference here is you can go for precise shapes, at the same time more finer, because you need to get the fine surfaces, at the same time fine crosshatch patterns. That's why normally the people goes for fine size of abrasive particle size. You might have seen the abrasive size in the grinding wheel specification. So coarse, medium and fine is there. So people will go medium to fine rather than coarse. If you go for coarse, the surface roughness will be very high. The piston cannot move as per the requirement, so the piston will fail, the complete automobile will fail. For that purpose, you have to go for the finer or a smaller grains or abrasive particles. Cutting fluids are used for the lubrication, that is nothing but dominating the lubricating characteristics, not the cooling characteristics. Okay, you have to choose a lubricant, not the coolant. If at all you want to go for very high speeds of reciprocation as well as rotation, in that circumstances you can go for very minimal amount of water addition to it, if at all you require, but normally it is not recommended. Expensive and time consuming, because this process takes lot of time. This is the disadvantage of this particular process, because the material removal rate is too less, because you have fine particles and the load spring relaxation will depend on your requirement. If the abrasive particles will remove very minute chips, that means that time for finishing will be very high. Summary of today's class: we have seen the grinding fluids after the grinding process, and fluid application angles, whether conventional fluid you can use, whether it can be used tangentially 15 degrees or 30 degrees, or what is the standoff distance, how far you have to keep, and all those things we have seen. The type of cutting fluids, whether people have used liquid type of cutting fluid, solid lubricants also people used. MQCF, that is called sustainable grinding process, is one of the concept nowadays people are working. So people, you can also work, especially those people who want to do research, they can go for MQCF in the grinding operation for machining of advanced materials like aerospace alloys or biomaterials or something. Wetting angle and wetting surface calculations, as well as software developed particle sizes, that is droplet size validation, and all those things we have done. That is in the MQL, what is the droplet size? Experimentally people have validated using Mavron experiment. At the same time they have also validated using the softwares by simulating it. And the honing process we have seen, and lubricants that are used in the honing process also we have seen. So honing process, keep in mind that it is lubricant type of cutting fluids you have to use, not the cooling type of cutting fluids. So thank you for today's class, and we will see some of the other conventional finishing processes in the next class.